we're going to be looking at pressure. Pressure is defined as the force applied per unit area, and the force is applied perpendicularly to the unit area. And a unit area represents 1 metre squared area. So the equation that defines pressure is force divided by area, and the units of pressure is given by the units of force, which is newtons, divided by the units of area, which is metres squared. So the units of pressure is Newton per metre squared, which is also equal to a Pascal. So if you have a pressure of 100 pascals, that represents 100 newtons per metre squared. So you have a force of 100 newtons applied perpendicularly to each metre squared area. So why do we look at the perpendicular force relative to the area? So if you see this example where the force is at an angle relative to the surface, well, it's the component of the force that is perpendicular to the surface that will exert pressure. The parallel component is not exerting a pressure on the surface. A knife has a small surface area, so for a given force that is applied, you can get a large pressure. And when you sharpen a knife, you're reducing the surface area of the blade to increase the pressure to cut food. A bulldozer has these caterpillar wheels that increases the surface area it has with the ground and hence reduces its pressure on the ground. This diagram is showing a dam, and you can see that as the depth increases, the thickness of the dam increases proportionally. And that's because water pressure increases proportionally with depth. And that's because the weight of the water above increases proportionally. And we're going to be proving this relationship between pressure and depth next. Here we have a vertical column of liquid of area A at the base, and to determine the pressure at the bottom of the surface, we use pressure equals force divided by area, where the force is the weight of the liquid above the surface. So that will be the mass of the liquid times the acceleration of free fall. So we can say the pressure is equal to the weight, mg, divided by the area, A. The mass of the liquid is equal to the density of the liquid multiplied by the volume of the liquid column. And so the volume will be the cross-sectional area A multiplied by the height or the depth h. So the mass of the liquid is going to equal the density multiplied by the area times h. So pressure equals density times area A times depth h, which is the mass, multiplied by G divided by A. So you can see that the areas A cancel, so we're left with pressure is equal to rho GH. And as rho is a constant for a liquid and G is a constant, you can see that pressure is directly proportional to the depth h. So that means if the depth doubles, then the pressure will double. Here we have a hydraulic lift where you have a large slave piston obeys the small master piston. And how it works is you apply a small force on the master piston, which produces a large force on the slave piston. So you can apply a small force to lift up a very heavy object. So for example, a hydraulic jack to lift a car. And how it works is that the same pressure that is applied at the master piston is transferred to the slave piston. And so the pressure at the master piston will equal the force applied at the master divided by the area of the master. And because the area of the master piston is small, you produce a large pressure. And so this large pressure is transferred to the slave piston. And so that pressure will equal the force on the slave piston divided by the area of the slave piston. And as you have the same pressure being exerted at the slave piston over a larger area, then a larger force will be applied on the slave piston. So to increase the force on the slave piston, you can either increase the force on the master piston or decrease the area of the master piston, because both of these will increase the pressure at the slave piston. And you can also increase the area of the slave piston.